going to cover the bridge on the Evernode contract. So basic contract at the moment, nothing too overly complicated. Most of this code right now is actually null and void. We're just triggering off the issuer, which actually issues tokens onto a network, and the bridge instance, which picks up transactions back to the issuer account. So if you send tokens back to your issuer account, it'll then save those transactions into a file, and then next time this contract executes again, the issuer will be fired, picking up all the transactions in that file and actually issuing those tokens out. So we split that out. I think there's going to be some timing issues, but that's the way it's done at the moment over here. So if we start off with the bridge has got a core processing function, which is basically just firing off this process, which is looking at the closed ledgers. So we're getting closed ledgers. We get the current ledger. So let me just go further down. So here we get the current ledger, and then we save that into a state, and then next time this thing fires again, our state is then there, which is in this transactions over here. We pull that out, and we again do the same thing, fetch current ledger, and then we fill the gap between the two, because certain ledgers on the XRPL would have passed, say 2 or 3, and say 2 ledgers passed on Zahao. And then what we do is we fetch every single transaction between those ledgers. So that's what this is doing. It's then looking for our transaction over here, that it has the properties we want with our token that we've issued from our issuer. Again, these are just hard-coded because it's proof of concept. It then saves those transactions into that file that I was talking about. So it sticks them in the JSON object and saves those transactions to disk over here. Right, and because this is Evernode hard pocket, it's persisting those transactions across all the instances of this contract that's running, right? Hoping that there would be 32, so you'd have 32 instances of this. That data would then be persisted across every single 32. Then, if we come back to our thing, so we've gone through one iteration, right? So we processed one ledger close on the Evernode contract. It's now going to fire again, and it's now going to come into our issuer, which has now got that data saved into the transaction file. This is now going to fire, and what this is doing is then taking all of those transactions that it found that moved value from one network to the other, and it's going to quote-unquote reverse those transactions. There's 2 states we have to look out for. If the user sent return fees back to that cold wallet but incorrectly specified the destination tag, because we're using the destination tag as the network ID identifier, it's going to return the value. So if a user erroneously sends back tokens to the wrong destination tag, all that's going to happen is this hook is going to give them the tokens back. But that's what that bit of code is doing over there. I need to remove that. This bit of code over here is actually doing the reverse payment onto the opposite network, right? So this, for instance, this was a transaction in Zahao. So they returned tokens on Zahao. It's now going to get into this bit of code, which is processing all the Zahao transactions, and then doing a payment to those people on the XRPL side, right? Sending them their return value. And then we do the exact opposite. We look for all the tokens on the XRPL, and if there was an error, return them. If not, we forward them their tokens that they sent to this bridge account or the cold wallet. I will do some transactions in another video. Leave it there.